Hello, this is a learning video on how to calculate an empirical formula given a percent composition. Here's the problem. You have a compound that is 54.52% carbon, 9.17% hydrogen, and 36.31% oxygen. You're asked to determine the empirical formula. So the first step that we are going to do is we're going to assume we have 100 grams. You can assume any amount of sample, but since you were given percentages, assuming you have 100 grams makes the math very easy. 54.52% carbon will convert into 54.52 grams of carbon. And with the given amount of hydrogen, you would have 9.17 grams of hydrogen. And with the given amount of oxygen, you would then convert that to 36.31 grams of oxygen. The second step then is to convert those grams of substances into moles for each element. So the first one I'm going to do is carbon, and you'll notice that I'm using dimensional analysis. The molar mass of carbon is 12.01 grams for every 1 mole. The grams go in the denominator because I want the grams to cancel and I want to end up with a unit of mole. So I do that math. I take 54.52 times 1 divided by 12.01 grams and I come up with 4.54 moles of carbon. I do the same for the hydrogen. I convert that into moles of hydrogen, which comes to 9.08 moles of hydrogen. And I do it also for oxygen, which comes to 2.27 moles of oxygen. The third step then is to divide by the smallest number of moles to find the smallest whole number ratio. So as I'm looking at my moles of carbon, my moles of hydrogen, my moles of oxygen, I notice that oxygen is the smallest amount of moles. So what I will do is I will divide by 2 for the oxygen, and I divide by 2.27 and I come up with a term of 2. So I take that carbon, the 4.54, divide by 2.27 and I get a number here of 2. When I do that to hydrogen, I get a value of 4. And when I do that with the oxygen, I get a value of 1 because 2.27 divided by 2.27 gives you a 1. These numbers now are the numbers of the smallest whole number ratio of the carbons, the hydrogens, and the oxygens in that compound. So I'm going to write the empirical formula by just putting these numbers as the subscripts. So the empirical formula then becomes, let's see if I can get it here, the empirical formula becomes C2H4O. These numbers that we just generated right here become the subscripts. Notice you don't write a 1 as a subscript in the empirical formula. Now, what if, when you were doing that work and you were dividing by the smallest number of moles, you ended in a term that ends in 0.5? It's not okay just to round this to 3. You will have to do some additional work. So if you end in a term that ends in 2.5, as in this case here, I arbitrarily put this number 5.68, that would be the moles of carbon we had, divided by the smallest number of moles, 2.27, and if I come up with a term of 2.5, you will have to multiply all of those terms by 2. You would multiply by 2 to find the empirical formula. So you would then have an empirical formula of C5H8O2. And if you ended with a term that ends in 0.333, repeating, you would multiply those numbers by 3 to get the lowest whole number ratio. If you ended with a term that ends in 0.25, you would multiply by 4 to get those terms to the lowest whole number ratio and apply them to the formula. So that is it. In summary, how to calculate an empirical formula given a percent composition. You're going to want to assume that you have 100 grams of sample. Step 2 is that you're going to convert those grams to moles for each element. And then step 3, divide by the smallest number of moles to find the smallest whole number ratio for the empirical formula and apply those numbers to the formula. If you end in a term like 0.5, 0.33, 0.25, you have to multiply by a number to get a whole number and apply then that multiple to the empirical formula. I hope this helps, and thanks for listening.